but I'll let her speak to that and not steal her thunder. So unless there are any general questions about this session before we begin, just raise your hand. And if not, then let's go ahead. Oksana, are you ready?
Yep, I'm ready.
Okay. So the floor is yours.
Okay. I wanted today to share with you introduction and a demo and how we'll be working in new analysis facility, Coffea Casa, the house for coffee. I will show some tutorials, but actually, sorry for confusion, you will be not able probably to run them because it strictly should be run only on facility and it's still in alpha mode, so we don't ready to scale for many users today, but yeah. And please, I recommend you to also to join tomorrow or today, depending for whom how, the tutorial, the maths presentation tutorial columnar analysis at scale with coffee, and see how full analysis will be deployed on our facility. So this is our team that we were working together. Of course, together with the coffee developers. And I will start with a short introduction. What is coffee? So coffee is column object framework for effective analysis, which basically allows to, it provides array-based syntaxes for manipulating high energy physics event data. And the nice part of it is that actually it pretty contrast comparing to well-established event loop techniques. It's a bit different. That's why it could be one of the pluses of it. So it's actually probably capable to fundamentally change time to scale science. A nice part of it that is nicely scales horizontally with multiple executors and providing efficient and flexible computations. Downside is that currently it's not probably easy to utilize it on current analysis facilities we get used like T2, since analysis is not really grid friendly, but actually meant to be more like interactive. From our point of view, when designing a facility, we were trying to understand how it could be done. So first part was to investigate which executors actually Coffee provides. And nice part of Coffee as well is that there are many executors, two of them local. So iterative executor, maybe, you know, it's just a process simple like chunk of data over single current Python thread, and futures executor allows to spawn multiple Python processes to process chunks of data in parallel on the machine. From the point of view of distributed executors, there are 4 types of distributed executors. So it's very rich. There is Parcel, a distributed executor, Dask, Apache Spark, and WorkQ. Our focus will be more today on the Dask, and probably I will start just with a short introduction. What is Dask, why Dask is cool, and why you will love it. Particularly, it was nice to see from the presentation of Jim that many people, many participants is not familiar with Dask. So I will try to do very brief introduction to it. Dask provides a flexible library for parallel computing. You need to think about Dask something like allowing you to have runtime parallel, but also as well plugging for the cluster execution for the Python. It's super easy installable by Conda. So you just do pip install Dask and then distributed. It's not really designed for the multi-user environment. I mean, out of the box, so you need to do some extra work. But a big benefit is that it integrates with HPC clusters, and it's running a variety of schedulers, including Slarm, HTC Condor, and multiple others via module Dask job queue. Here's a simple diagram how it works. So you have like a collection in case of if you use, for example, standard Dask collections such as array or data frame or Dask delay or futures, then it generates for you task graph. And then after this, scheduler helps to execute the tasks on the single machine, like threads, processes, or distributed, and allowing you to access even clusters. Let's just check out the simple example, what is actually Dask and how it works. And so I'm starting a client from Dask distributed. Here's our scheduler. We have actually dashboard from which we can check out the status of our execution workers. We find one worker with 8 cores with memory 4 gigabytes. Let's try to generate a random the array of random numbers, 10,000 per 10,000. And here it's interesting part that they will be represented like many NumPy arrays in this case. So each of them beside 1,000 and 1,000. So you have, if to do a calculation, so you have 100 NumPy arrays, each of them of size of 1,000 per 1,000. And here we need to see, so how many tasks actually this, so we have all stats about tasks, about size and shape and types of it. Let's do some simple operations. Okay, and finally execute it. Yep, so it's just super simple, super easy. And the question is like, why Dask? What is the benefits of Dasks? First thing, as we see that Dask scales really easily to single computers. So it can enable very efficient parallel computations on single machine. And taking into account multi-core CPUs and streaming data nicely. And in this case, basically, it extends somehow concurrent futures. Then Dask can scale to the clusters easily via Dask distributed and Dask job queue. It nicely integrates with the Python code. So it's just a very nice addition to the all well-known libraries. You just install it and use it. The other interesting part that Dask supports complex applications. So actually, since it exposes low-level APIs, so you can actually use internal task schedulers APIs to execute very complex computation. And for example, implementing your own custom logic there, similar to our case that we will talk later. Dask is very interactive, so it delivers you responsive feedback, monitoring via real-time, responsive dashboard, profiler, built-in embedded IPython kernel. So yeah, it seems cool. Finally, what about our analysis facilities? What if we have a chance to build now a new analysis facility, what we would like to see from it? And this is like some requirements that we collected. So it should be easily to be used by users. It should be scalable, both dynamically and automatically. It should be interactive, of course, and responsive. It should use currently deployed hardware and middleware, so we should be able to reuse. It should be minimally intrusive for site administrators and also accountable for experiments, for example. Looking on the platform on which we were going to develop, we were actually started to look in Kubernetes. Yeah, I think like everybody probably talking about this, and it's pretty old project, so it's 6 years old, and over last years is getting more and more popular, and now it's like the number 3 most loved platform. What is it? Is actually a platform that allows to run and orchestrate container workloads. A bit of motivation why we were selecting Kubernetes. So it's very extensible and developers love it. It has a description of infrastructure via a YAML, so you can easily express everything you want there. It's very scalable, it's time saving. It has version control, which was very nice to use when we were able to roll back to early deployment and test all our new features. And then in case of something going wrong, we were able to quickly to just go back to the previous version. It has a lot of other nice features, particularly like security controls. It has a nice set of existing resources already described for you: pods, deployments, secrets. Otherwise, if you are not happy with this, you can as well extend it. And the other biggest aspect of Kubernetes popularity is its strong community. So this is what was our first brainstorming schema, which we came up. Basically, we would like to have users with its laptop. Then we built all our infrastructure on top of Kubernetes cluster. We were looking for having definitely Jupyter Hub instance for providing interactive analysis. For efficient data management, we wanted to use Xcache because we already have it on UNL. And as well, the other benefit is that since it is, we have HTC Condor pool dedicated for our T2 on Nebraska. So we wanted to be able easily to scale to it. The challenges that we were facing, that usually user management on T2 is not really easy thing. So we were thinking about to have user access management over some different administrative level like SSO or CI login. We didn't have that much experience with Kubernetes, but we knew how works Docker. The problem of efficient analysis is probably to provide a nice performance in the terms of from a point of view of data management, caching, and we needed to make some integration and performance study to understand how it actually works. It was not clear how it will work all together with AAA and batch system, and as well we didn't have that much experience on Jupyter Hub management. So this is probably a bit of story how we were. What was our steps in configuration? So the first step was enabled token authentication HTC Condor infrastructure. It's something available for the in latest releases of HTC Condor. We set up the K8 cluster and then used such a nice project 0 to Jupyter Hub. You can Google it. It's extremely nice projects with a lot of documentation, and you can try to build by yourself everything that we did kind of locally even. Then we develop a highly customizable CMS analysis container with all necessary dependencies. Jupyter Pub, we decided that it will use, it is using Kubespawner to create new pods. Inside, we added the pod customization hook to create secrets and services for such a for services such as services as HTC Condor and X-Ready. So next step was integration of X-Ready. Each pod has a unique secret included. It's auto-generated macaroon, which is authorizing the pod to access files on the UNL Xhash server. There was also developed custom X-Ready authorization client plugin that allows us basically in clever way to enable token authorization and as well to use a special way to access X-Ready, Xcache, sorry. Then the last step was already HTC Condor integration. We used the HTC Condor cluster class from Dask Job Queue that allows us really easily to autoscale in local HTC Condor pool. For security, we have TLS enabled communication between workers and schedulers. And all these things are incorporated in, most of these things are incorporated in Helm chart. So basically it should be portable to other sites. So Coffea Casa, why you will love it. Yeah, first thing, you don't need any more X509. You have nice authentication via CI login and then WCG Bureau tokens, macaroons. We hope to provide enough security with TLS over TCP sockets. You don't need to think anymore about X-Ready because we use Xcache with the new X-Ready authorization plugin. And basically it allows you to have grid style analysis, but from the Python notebook. About Xcache, I was talking a lot, but probably I need to stop for 1 minute just to explain what is it. It's basically our access point to AAA, which is any data, anytime, anywhere. It's like a Squid-like cache, but it primarily uses X-Ready protocol with HTTP on top. It allows you multi-threaded file caching applications that can synchronously fetch and cache file segments. And it's built on top of X-Ready. And so, yeah, this is the next part will be about this authorization flagging, and I wanted to show you a bit of magic. In fact, I'm running this notebook on our analysis facility. So basically, you see, we just try to fetch now CMS related data easily. About secrets that I was saying, we have all of them available in directory on container startup. So it's certificates, Condor token, useful for submitting to T3Q, and host certificates and private key, and user certificate and private key, useful for Dask scheduler and Dask worker. This is a links for our, let's say, building blocks. If somebody would like to, wants to repeat this exercise or is interesting to see how it is deployed. Yeah, the most important question, when you will be able to use it. So alpha version is expected to be available soon. It will be available for preliminary tests by CMS community. Ask your friend for invitation probably. And we hope having it fully available during fall, winter 2020. So now demo time, and let's see how it works. Actually, I think I'm going even pretty quick, so I will have enough questions. So, just a second, I need to stop. Oops. Yeah, so this is like, I think this was already mentioned. It is a set of the benchmarks that were proposed some time ago for evaluating different analysis frameworks, including our data frame and Coffea and etc. And I'm just trying like a very simple example. First one, plot missing ET in an event, so loop over events basically. I'm not a physicist, but yeah, I just wanted to show you how it works. So let's see. We're starting our scheduler currently. It takes some time to bring up workers. We'll try to see what is happening on our Condor queue. Okay, we start to see that actually somebody is already running from our facility, and this is our job. We're just starting. We have a progress bar that helps us to understand what is happening there. We're using the proper Coffea method run approved job, where we specify as an executor, task executor. And there is our workers starting. Everything over TLS, as you see. And so we developed some kind of our custom wrapper around Dask Q HTC Condor cluster, where we just trying to simplify all our settings that are and develop custom logic of submission. So for this, we need just to say the worker image that we are using here, say how many jobs, say if we want to use TLS or not, and then voila, we get results. Yeah, so here we were actually not using Xcache, and I need to close it. So here's a bit more complex benchmark. It's again from the same set of the benchmarks. Basically here we what we try to do is we check the events with more than 3 leptons and the same flavor opposite sign lepton pair, and then find the best same flavor opposite sign lepton pair, and then plot transfer mass of missing energy and leading over a lepton. Okay, let's try it. So in Binder, I just added the already checked slides and check notebooks. So after you will be able to check out how it works or check the code if you're interested. In fact, I'm not sure if Matt is connected. It's mostly these benchmarks were done by Matt. Okay, here works again, which is good time. Second time it works. Yeah, it takes a bit of time basically to bring up, as I told, all our workers, and as well this is our Condor jobs. And as well, we have but we compared the performance versus like Dask local execution, and we show pretty nice results. So it's pretty reliable, even though each worker has a small 10 seconds sleep just to be able to have verified connection 100%. So you need to remove this also from the count. Yeah, so I think it's pretty nice way to replace the boring old style grid analysis with something interactive. And it's pretty quick, so you probably will not be able even to make a coffee while waiting. Yeah, almost there. So nice part is that we can also enable auto scaling, where you can say, for example, the maximum and minimum jobs that you would like to have. And then Dask will, in very clever way, it will decide how many workers should be released, how many workers should be brought up. So in this way, it's actually even much more flexible. And the last one, where I just wanted to show that Xcache is working actually nicely. Yes. I wanted also to show you how works the dashboard. I just totally forgot about this. This is something very powerful, which is, I think, very attractive from the point of view of users. So here, as you see, we're accessing a lot of files from Xcache via Xcache. It's a very simple benchmark. It's really nothing special. It was basically just to test how it works. But yeah, so scheduler is up, dashboard is there. We're receiving connection. And we can access, still not up, workers. Okay, workers are up. So this is the task monitoring, where you can actually see with the green, you can see how is going our task stream in. The gray is serialization, red is dependency gathering, orange is disk.io. We can also monitor CPU utilization on workers. We can check memory easily. How many bytes we are storing? 10 gigabytes. Ooh, yeah. The nice part, we can do profiling, which I really love. I think it's one of the greatest features that you can immediately see the bottlenecks of your code, how it is executed, and etc. on the lifetime. You can actually see even the activity over time. For example, let's see something interesting. IP kernel, NumPy. Yeah. And I wanted to show before it will finish, this was worker monitoring. So we can see how much memory we use, CPU, memory limit, and as well the matrix of bandwidth, and find our best bandwidth spots. So let's see how it's going here. Okay, we completed actually. It was only 1 minute. And this is like probably a stat that you can see from our desk client. So in total, it took 103 seconds, and we used so it was in average 8 megabytes per second per thread, but mostly it's more actually. It's probably I need to change a bit processes, and it is 167 approximately megabytes per second with 450,000 events per second. So nice stats, could be better. Yeah, so it's everything from my side, and I managed to finish a bit quicker. It's pretty late here, so I hope you enjoyed. And yeah, please let me know if you have some questions.
Thanks very much. That was a really nice tutorial, and I think a great intro to Coffee. We do have some questions in Slido, so what I'm going to do, sorry, bear with me for a moment. I'm trying to flip between screens.
Yeah.
Too many tabs open.
Should I ensure?
Yeah, so if you can still stay sharing, I'm just going to in the Zoom chat, I'm going to paste this link to the questions. So if you could flip over, if you could open that in the Zoom link, then we can go through the questions there. And that way everyone can see them.
Wait, how to go to the chat? Oh, okay, I see it finally. Okay. Yeah. Okay, works. Cool.
Okay, great. Right, yes. Oh, this is really big and highlighted. Okay, so yeah, maybe we could first just kind of go through the ones that are the most upvoted. So we have Condor can take a while to schedule task workers if the system is busy. How do you plan to optimize this?
And currently we have actually even separately allocated slots in the queue for this facility. So that's why you saw we never been that much busy and etc. But it was idea to also have like a mix between local executors and as well HTC Condor executors. So have something like something available now, and while you're waiting in the queue, maybe to have some computations for then. Yeah.
Sure. Okay.
Yeah. So you mean by that every person gets kind of a minimal allocation that they always start from, so they're always getting some throughput, and you expand dynamically.
Yes, and of course, everything depends on the hardware we have. So currently, we just use the old hardware, but it seems to be a lot of interest. So hopefully, we will expand, and we will have some kind of mixed mod to. The other thing is that we're investigating lab extension, which allows us to already when you kind of log in, to create for you on demand your own HTC Condor cluster with a minimal amount of workers there. And basically it works here. So you have this magic button. It's still not implemented. When you click new, okay, yeah, it's not implemented. And you have here your own cluster defined for you. And then you just don't use anymore here, where is it, Coffea Casa cluster, but actually you can use like client with AP here, and it will start from there. And then with auto scaling, we can automatically scale. Yeah, so we have a lot of options basically, shortly investigating all of them.
Yeah, nice. Okay, yeah, so maybe we can then next take Gordon's question. All these new infrastructure plugins, are they available to everybody? So that is, can the people that are in Atlas, can we take advantage of these things as well?
plugin is basically in GitHub. You just build X3D and then build plugin together with where you have X3D installed. I think there was we did kind of even packaging for it preliminary, but it's only available for CentOS 7, CentOS 8. So yeah, it's something to think about. Probably since we are doing this work for last 1 month, we will try to organize it probably better, so make it available for everyone.
Great. Yeah, and then if you don't mind, we have still a few more minutes for questions. So,
absolutely.
Okay. Yeah. So then also, so I was just curious. So you mentioned that Coffee is still in alpha right now, but so I'm curious, what's the
Not
experience
coffee.
that you've
Coffea Casa. Coffea Casa.
Coffee Casa. Okay. Okay.
Yes.
I'm all right. Sorry. Yeah, that was my bad. Okay, so replace that with Coffee Casa. But when you have people, when you're onboarding new users to the whole experience, have you found that they pick it up pretty quickly, or is it something that that you've been iterating the onboarding process on as well?
So we were thinking, basically, you saw it doesn't require any changes in the code except of maybe adding one line. We were thinking to do kind of the gallery of examples where you can easily go and check out something similar to how it was done in Swan. And I feel it's really pretty easy for new users to start to use it. It's very, you don't need to set up any parameters, you don't need to set up anything, you just need to log in to have, I can even show quickly. It's basically looks like this. You have just, you know, window, you go to CI login, yeah, I'm sorry. Yeah. And then I'm logging and I'm there. Okay, a bit more. Yeah. Now I'm there, back in the same place where I was before. So it's pretty easy.
Yeah, that's impressive. Okay, and then we still have a few more. So Peter wants to know, how flexible is the user environment? So are you locked into a specific Python version, and do users need to reinstall any needed packages for every job submission, or is that kind of all just packaged up and provided for people?
So we have, let's say for the worker, we have a Docker container, which has all needed packages, for example, for Coffee and Dask to be working. But from the point of view of flexibility, okay, I will just stop my server, and I would just want to show you when you start actually a server, you have a choice of different environment, different images, and probably it could be nicely extendable, easy. So you can put your custom, yeah, you see here, Coffee base image, minimal environment, data science, curl test image, here be dragons. So yeah, Spark environment. Yeah, I hope I managed to reply.
Yeah, that looks really nice. All right, and then maybe in the last minute, we'll take one final question from Ben. How detailed is the profiling? Is it limited to just the processor level, or can it dig into what's happening within the processor itself?
Yes, I'm sorry, it was very short benchmark, so I didn't manage to show more. You can actually, so it's Dask developed their own built-in profiler, and you can go and check out what is happening with the processor. You can select what is happening For example, in serialization, you can select different so you can go as deep as allows Dask to see from
It's
the point of view.
profiling. Sorry to step in, but it's
Yeah,
profiling the
please.
whole. It's profiling the whole Python process, so you see everything that's happening.
Yes, yes. Thanks, Lindsay.
Fantastic. That's really, really nice. Okay, so we're basically almost at 17:45. So thank you so much for this really nice talk, Oksana.
Thanks.
And yeah.
Hope you
Okay,
enjoyed.
so yeah, definitely.